Hi, good morning, everyone. Thank you for coming this seminar, and then also very happy to coming here in the Lab 5. And then we're gonna start the seminar called Implicit Behavior of Emotion Contagion by Professor Katsumi Watanabe. So let me introduce him from myself. So, Katsumi Watanabe is a professor at Waseda University, and he's a Department of the Intermediate Art and Science, Tokyo, Japan. He received the BA in the Experimental Psychology in MA and MA in the Life Science from the University of Tokyo, and his PhD in the Computational and Neural System from the California Institute of Technology for his work in the cross-modal interaction in humans. He was a research fellow at the National Institute of Health, USA, US, and research at the National Institute of Advanced Science and Technology in Japan, and associate professor at Tokyo University Tokyo. And his laboratory research focused on the perception, cognition, action, and decision-making, social perception, individual difference, the brain function, and the affective science. The main theme includes the scientific investigation of the explicit and implicit process in the human perception, cognition, and action, interdisciplinary approach to the cognitive science, practical application of the knowledge of the cognition and neuro and affective science. So I'm very happy and also honored to introduce him because he is also one of my favorite and also most respectable professor and researcher in the cognitive science. So I think you're gonna having a very nice talk and also enjoy his talk. So thank you so much coming here.
Thank you. I think this is summarize my thing. Somehow you can tell everything. So because I'm starting as a trained psychologist, a so-called experimental psychologist, and then just went to Caltech, and then just going back and forth in Japan, US. So I've done a bunch of things. So probably you can see that from after getting out the psychology department, I never been in a psychology department, always in the engineers and all the other stuff. But I have something in my mind. Somehow we can study the mind, we can study the brain, therefore we can understand the people. Then as long as you have this kind of the mind, you can just do whatever you want. And then we have done a bunch of things, but just forget about this. Now we are talking about I want to talk about two approach. One, the minimalist approach, which I have been done as a psychologist very rigorously, which is a classic way of doing science, and also the inclusive approach, which we have been starting recently, which I have been struggling with. But I want to just tell what we are doing here. So let's start with minimalist approach. And then I've been talking about this stuff, but I didn't know that it's just 1 hour, so I don't know how much I could go, but I just try to do as quickly as possible. So how to study the social interaction? One possibility is just talking about just a higher level of social interaction, talking about the language and some like empathy or that kind of things. But as a minimalist approach, we want just squeeze into the very minimal social interaction so that we can study the social interaction. One thing I'm amazed by the so-called behavioral contagion, which is somehow we speak faster. If one person speaks faster, the other person try to speak faster, and the other person try to speak slower, you couldn't speak faster because the other person speaks slow. So it's kind of some tempo alignment between the two people. And then the behavioral contagion is everywhere, and starting from the born. So, there's a famous one. Somehow the newborn baby tend to assimilate the other person's face. This is kind of very mysterious, because in order to do this, the baby must know this part of the face must be correspond to this part. So therefore they can do some behavior assimilation, and also the children learn by imitating the adults. Then we can just do this behavior imitation by using the very complex stimuli, but we can just squeeze into the very small information into that. It's it's called biological motion, which is basically you are putting the light on each joint so that you can see the moving people. But by just watching these things, somehow you can understand how people are doing it. Then it's very easy to do. The top one, it's people walking. The bottom one, you can see people just dancing there, even without having these actual body there. Then just showing this stimuli, the experiment is going like this. You're presenting a stimuli in fast speed and slow speed. It's very simple experiment. You show the fast speed biological motion, slow speed biological motion, normal speed biological motion, and then press the button as quickly as possible. That's simplest task. Just try to push as quickly as possible. And then just keep doing that. And then if you're just presenting the slow speed and normal speed, this is just a jogging, but still slow speed, normal speed, and fast speed. After watching this, your task is always the same. Just press the button as quickly as possible. The one prediction is that after seeing this fast moving stimuli, somehow you press quick button quickly. And if you press showing this slow one, you couldn't push the button quickly. And the good thing about this biological motion, you can have a control, which is a experimental psychologist really value. So you have this scramble biological motion, which you have a randomized starting position, so that all the motion energy, all the local motion is exactly the same, but it doesn't look like a human now. And the question is whether you can get the same effect. And actually, you found only if you're presenting the stimuli in biological motion, you get a faster reaction time here. So that means it's a social interaction. It's not a stimulant interaction. And also, it's very important that if in normal condition, you think this is a limit, your reaction time. But somehow you can over the limit, you can exceed the limit if you saw the other people moving faster. So the behavioral tempo may be contagious even for a simple discrete movement, and it is somehow it's contagious somehow. And also the third part is, for me, it's very important for me, that somehow physical limitation or psychological or social limitation. So you think this reaction time is your limit, but if you saw the other people doing better than you, or better than average somehow, you can do better than what you are thinking about. So this is, I think, a very minimal social interaction. Only if you saw the stimulus as a human, somehow you get this influence. And then I go further. Somehow, what is the minimal interaction of the people? So now I'm going to present the behavioral mirroring. The task is something like this. It's really weird experiment, which one of the weirdest experiments I have done. Your task is to do nothing. You just keep finger still. But if you keep finger still, you will see the finger moving a lot. It's fluctuating. So in these days, people don't use so many time for the laser pointer. If you see the laser pointer, it's fluctuating this. Then task is like this. You keep the finger still on there. That's your task. Okay. But there's another guy doing the exactly same you do. Then this is actually a movie. It doesn't make sense to make a movie, but your task is just keeping your finger still. And then we measure the position with these fingertips and how much this fluctuation assimilate to each other. And then this is a typical movement. But you can see although you want to try to make the finger still, these positions tend to assimilate to each other, and you don't know about it. And if you just compare it in two people, you get just take a cross correlation of the two fingertip, and then somehow the finger position tend to assimilate to each other. And compared to the swapped condition. Swapped condition is that there's experiment participant A and B, and participants C and D, and you get the cross correlation A and B and C and D. And take a cross correlation on A and D. And just because the task is to make the finger still, people tend to go back to the original position. There might be some absurd correlation there. It's just for the 1 minute, very simple task. If you take an original shuffle, you get some change in cross correlation. That means just the other person doing the exactly same thing what you're doing, somehow finger position tend to assimilate. So that's basic. Next experiment, this is interesting part. So we did an adaptation experiment. So here, the one of the participants assigned the reader, the other person assigned the follower. The reader moving their finger, reading. The follower following their finger for 4 minutes. So this is adaptation. And we sandwiched this adaptation in the pre and the post measurement. And the pre measurement, you do the exactly same. Your task is keeps the finger still. And the post, you do the exactly same task. But between them, there's the adaptation period. which the reader moving the fingers freely, the other one try to follow it. Then just imitating the other person's movement for 4 minutes. Is there any change of this cross correlation between the pre and post? That's a very simple task. And actually, it's the increase of the so-called synchronization or assimilation between two people, just following the other person for 4 minutes. So just if you just try to imitate the other person for 4 minutes, you couldn't help, imitating the other person, and even though you shouldn't do that. So that's an enhancement of cross correlation. We call it behavioral mirroring after following the other movement for 4 minutes. And after this, we did experimental psychologists do a bunch of the control. We have a 20 control condition, but I just pick up some of the most important one. The one is just during adaptation period, follower doesn't follow it. You're just watching on. You don't move your finger. The question is, where do you get the effect? You don't get it. So you need to follow the other person's finger for 4 minutes. So that's very important. Then maybe, if you just try to do it 4 minutes or following, you get tired of the muscle or something. Therefore, you can get some kind of the effect. So now it's the reader moving the finger freely, the follower moving a finger freely too. Then I'm taking just a peek of the cross correlation. You don't get it. So you need to follow the other person's finger for 4 minutes in order to get this kind of enhancement. And the final part is one of my favorite, which is reader moving the finger freely. The other one following the reader's finger, but the reader is blindfolded. Okay, the reader is blindfolded. They are not followed. They think they know that they are followed, but they don't know how other person doing. Then this is following the movement, except that the experimenter was blindfolded, and you don't get it. So that's a very important point. In order to get this effect, you need a mutual interaction between two people to enhancement of this implicit body movement. From that, I am just speculating that there must be some, the reader must know that you are followed by that. Or maybe reader is just moving it's same as your suggestion. Maybe the finger movement is somehow to make it easier for the other person to follow it, so that they have a more mutual interaction between them. Then one question is that adaptation to the human in general, or it's adaptation to the person? So here in the pre and post test, and the A and B and C and D are matched pair, but in adaptation we switch the people and come back, and then it turned out to be it's going to be the person specific. So the adaptation is that kind of person. It's not for the people in general. So that's a person specific, and also we did some correlation between how much you enhanced this body movement, or body assimilation of behavioral mirroring. It's somehow correlated with the communication scale of the AQ scores. So if you have better AQ or lower IQ score, which means the better communication in a sense, somehow you get a better adaptation to the other person. So it's somehow it's a very minimal interaction. It's somehow related to the actual the score on the real life, let's say. And after doing this, so this task is ideal to measuring the brain because you don't move your finger. And then we did some kind of hyper scanning of the brain. Two people, as we do the exactly same things, but we're measuring the pre and post session. We measure the brain activity with the two brain, and which part of the brain is somehow making this change of the behavioral mirroring. And I'm not going to the detail on that, but somehow there is some interaction between the brain, so that which explain the increase of the body behavioral mirroring. And then the third part for me is very interesting to me. The mutual interaction is important. Therefore, there is a minimal social interaction. You must do nothing, but somehow the interaction occurs between two people, even though they shouldn't do nothing on that. And then there must be some brain foundation for that, which I'm not get into that. And then, but this procedure could be used for the various kind of the control condition, which everybody can come up with a control. So what will happen with the robot and humans, and what will happen with the virtual avatar and human, and then what kind of things happening between these agents. So we have this kind of human-human interaction, the minimal social interaction, how we can just make the other agent, like a robot or avatars, can be more human-like. Okay, then now we are talking going to move to the interpersonal coordination. Now they're going to be task. Two person do the one task, and how these interaction evolved. And then there are two interpersonal coordination in a sense. One is implicit, other is explicit one. And I'm interested in the implicit one, somehow how people contribute into the one task. And then we divide this task. Is that this implicit role taking task in the motor collaboration task? The task is simple. You have a button. You have a sensor. If you push it, the X mark just go up. Okay, and you need to keep the, say, 10 Newton of the power. You just keep it. So your task that you can just do that. And you have you could have two sensors, and you can do it by yourself by left and right finger, so that you can make the floating the marks on the monitor. And we can divide into two people, and one person doing this, other person doing this, and they together somehow need to make the mark on some certain line. And sometimes you get some perturbation and changing the gain or something, but your task just keeps this X mark on the line. But the two person can know only in the sum of the two force. So they don't know, how much you're contributing. Here is a task. And we did it in task in when our University Tokyo did some open campus things and just open to the public. They just do this task. And here in the combined force shown, just you get this one X going up and down. You get a very good, performance. You can keep the X mark on some kind of the force. But if you just divide into the two force, which we only experimental know, there's a huge difference in terms of how much they contribute. The one person doing most things, the other person they do a bit, but somehow, also didn't do too much. And then somehow, there's always different pair, husband and wife, and supervisor, and then, student, and then usually the bottom one is a supervisor, top one is always a student, and like the bottom one is a husband, top one is a wife always. Then if you ask them, which one did the best? Which one did most of the task? You don't get correlation. They don't know how much they are contributing on this task. But then when we did this task for many people, there's a very typical wave drift. And then one person getting contributing more, the other person getting less. This happening very naturally without they knowing. And if you just repeat 4 times in the same person, you get the exactly same pattern for 2 persons. And these 2 persons are unknown. That's first met. And but still they somehow making this pattern, very robust. And if you ask them, whether how much you did more tasks, you did a less task, or it's in the middle, there's no correlation at all. So, which is a kind of very minimized part of the society. Somehow, if you do the one task, you think you did best, you did better, or you think you did less, but somehow actual contribution is unknown to the people. So we just very simple. It's a very crude model somehow. Is that this is only explained by the motor variability or the actual power of the difference between people, or if you're putting some social score, did you get the better explanation on that? And it turned to be, well, it's not very significant, but still the social score or social factors somehow explaining this, how much you are contributing And also, if you get some who gonna be responding to the sudden perturbation or some change of the gain, and it turns to be the people who are having a higher IQ tend to respond to the this change. It's kind of against them because they are not social. I would say they might be social, but it's not. Somehow, it means that the person with a higher IQ, the pair tend to more to pseudo error. So it seems like they are not trusting the other people. You need to do your task for yourself, and you cannot let the other people to respond to that. So this is a kind of minimalist approach in the sense that making it a social. We're never talking about social interaction. People thinking about the very higher level interaction, having empathies and language, but you can just picking up the very the subtle body movement, very subtle interaction, which can explain, can be manifested as social interaction here. So, which we haven't done too much, but it's also we have done this one 10 years ago. We need to do more, but recently we did some MRI hyperscanning, which part of the brain is used for this task. And then I tend to be, I don't get into the detail because I'm more interested in behavior rather than the brain. Sorry, I shouldn't say that I'm not in the brain, but somehow that is like a mentalizing process and somehow empathy process somehow involved, even though this is a very simple task. This is a higher construct is working on this condition. Then this is just a bit of the, always I
ask
about time.
We can keep.
Okay, This is now it's emotional contagion, which have been done about 5 years ago or something. The idea is very simple. How much you can contage by your own voice. That's an idea. Then basically the idea is simple. You can just modify your voice so that you can just sound more sad, sound more happy. It's going to be affecting your emotion actually. And this contagion is very it's more like so it's baby looks good. Now you looks good. Okay. And then dad is very happy, and then she or he likes really to tear up the newspaper. I don't know why this is interesting, but still, you think it. And after seeing this, it's really fun. So, and the next part, I really like it. Now, baby, watching people, like dad, and just you're gonna do this.
You gotta rip it, yeah. You gotta rip it, yeah. You know what's coming. Grab it.
Yeah, so that's really contagious. Then the theoretical background is basically it's called the James Lange theory of the emotion. That because basically we cry, therefore we become sad. So I want to just test this by including some emotional filter on the voice, and then if you speak this is Haruki Murakami's novel. The task is just read this Haruki Murakami novel for the experiment. So just ask them to this is for the experiment this is just for the making a stimuli for the other experiment. You just need to read it. And then if you read that, and then whenever you speak a word, it's coming to your ear in different tone, sadness and scared. And then we need to somehow mask the bone conductance by using the bone conductance speaker, so you can just shut down the actual feedback from your voice. Then just say that the results show that you got bias toward your sad voice and scared voice. And we gradually changing the voice by using 7 minutes, they're gradually changing to the sad, gradually changing the scared. So therefore you don't notice that you are manipulated. And then this filter is available there. It's just it's called sound manipulation, sound making called Max, and there's some filter on that, so people can just easily do the how you change your voice now. Then it's very interesting to see that you are contagious by your own voice. Like I said, it's more like you can affected by the other people, but you can just change your mind or your mood by changing a voice tone too. And then to be honest, it's we hope that we're gonna make it as happy voice so that people can become happy, and even if you get somehow you're getting some depressed, your voice gets depressed, you get a negative feedback on that. If you have, maybe you can just change the voice a little bit so that make it the voice normal. Maybe you can just prevent getting to downward things, and with you can even make it people more happy feeling after making a happy filter. But it turned to be that making a happy filter is very, very difficult. Making a sad filter, making the scared filter is easy. To be happy, somehow people speak faster, and filter couldn't do that. Somehow it's very difficult to make the people happy, but we are working on that. Also, they have another filter, like a confident filter. Like if you speak in that, you sound like more confident. Is it possible that you make it more confident while speaking on that? So that's another thing. And also this filter is interesting for the scary filter. If you're applying for the violin or applying for all the other sound, it also looks sad in a sense. But even for the musical instrument, you can make it sound like sad than normal. Okay, thank you. It's broad too much, but if you have a question, just ask me, and or you can just send me an email, something, so that you can just I can just respond to you. Thank you.